everyone. Starting from this video, we're going to look at the two questions and that allow you to really apply what we just learned about hypothesis testing to actually solve some problems. Okay, so again, I want to recognize your feeling about this chapter is extremely difficult. I think that's what I've been experiencing, even being as a student. And now as a professor teaching many students, I think hypothesis testing is a little bit challenging, especially try to wrap around your head around about, hey, are we testing right or wrong? So therefore, I hope this practice question are able to teach you the practical steps so that you can follow through to learn, right? So to work on your homework, as down the road, if you practice more, you will develop a further and further of understanding about hypothesis testing. So I don't want to say the end of learning of this chapter is the end of learning hypothesis testing. I want to say actually this is the beginning of you learning hypothesis testing. As you take more quantitative analysis classes and also go into the real business world to solve a business problem, you will notice that, you know what? Hypothesis testing is everywhere. And as you add more and more real world experience in this space, you will realize the beauty of the hypothesis testing. Okay, so therefore for this video, we focus on the question number 1. And so for question number 1, we focus on to practicing the learning object 2, 3, and 4 here. Basically, we want to know how to do the hypothesis testing, the left tail, right tail, and the two tail. And of course, you need to know which test is one tail, left tail, right tail, or two tails. So therefore, question number 1, there's no business context, just literally ask you to do the hypothesis testing. And so I already supply you with the Excel file. Make sure you also download this file as you're watching this video. So I want to developing this problem solving habit so that you feel comfortable using this kind of setup to solving any hypothesis testing questions. Okay, so let's look at the question together first. Question number A is given the mu equal to 200, HO is mu equal to 200, and H alternative is mu not equal to 200. So as you can focus on based on your H alternative, your H1, and you will be able to know are you facing a two-tail test or one-tail test, right? So since your H1 is mu not equal to 200, so that means this is going to be a two-tail test. So that is what we are focusing on, is a two-tail test. So since this is a two-tail test, because mu not equal to 200, and that's your H1, so that tells us we're going to do that is a two-tail test. Let me go back to my Excel sheet here. Okay, so therefore we are using this question, this column. We're going to fill in this table. Let me creating this as a table. Okay, so we're going to fill in this table to answer our question number A. Okay, question number A. Okay, so now given the mu equal to 200, the hypothetical mu value equal to 200. So we're assuming the population mu equal to 200. And then the alpha, the statistic significant level is 0.025. And the sample mean is 203. The sample standard deviation is 8. And the sample size 16. So given all those information, we are able to perform a hypothesis testing. Okay, so now let me go back to putting all the information I needed to the Excel file. Okay. So the sample size, let me shrink a little bit. Okay, so the sample size, as we are reading this case, and we learned that the sample size is 16, and the sample size we are given is 203, and then sample standard deviation as equal to 8, and the hypothesized value we are given is 200. And then here we also want to add in that alpha value. I didn't include it because usually I use default value. So the alpha here is 0.025. Okay, so given all those information, and then we are able to start to do the hypothesis testing. Okay, step number 1. What is your hypothesis? So your hypothesis HO is mu equal to 200. Your H alternative is mu not equal to 200. Therefore, that's why you know this is a two-tail test. Step number 2, calculating the t statistic. Okay, so I know I have there. So we are going to calculating the t statistics. So to calculating the t-statistic, here I was introducing the standard error because we defined that before. Basically using the s divided by square root of n, that gives you a standard error. Okay, so basically we are going to calculating the t-statistic. Before we do that, we need to calculating this sample standard deviation, standard error here. So this is equal to the sample standard deviation divided by SQRT, taking the square root of the sample size. Okay, so basically we are trying to follow this formula to calculating the denominator here using s divided by square root of n. So we give that name called the standard error. Okay, we push enter, so we got 2. Now we are able to follow this formula to calculating this t-stats. So this equal to parentheses, don't forget because this is your numerator. So parentheses x bar, so that is the sample mean, minus x mut is the hypothesis mean, so which is 200 here. Close the parentheses, divided by, if you focus on this equation again, so divide by the s divided by square root of n, so that's my standard error. Okay, I divide by the standard error, and I push enter, and I'm able to obtain my t-statistic. So the t-statistic here is 1.5. Okay, step number 3, critical value. Okay, so what is the critical value? And then, so if you don't remember, let me pull out my PowerPoint again. So when we look at the two-tail t-test, right, so this is another example. So we need to look at the two boundaries of the critical value. Okay, the critical value, first of all, we are using t.inv.two-tail test to determine the upper bound. So we basically first determine this bound and then adding the negative sign that will give us the lower boundaries. Okay, so we're going to using this formula. Okay, so for the t, the left tail, right tail. Okay, so the critical value, we're starting from the right tail because it's a positive one, will be equal to t dot inv dot 2t and parentheses. And the degree of freedom gonna be the alpha we are picking here is 0.025. And then the degree of freedom we mentioned in the class, it is equal to n minus 1. So basically 16 minus 1, that will give you the degree of freedom. So that will give you the upper tail. Okay, 2.48988. And then my lower bound will be equal to, I'm just copy this again. Oh, sorry. So the left tail will be lower tail equal to that times -1. Okay, so that gives you our left tail. So basically for this specific example we are looking at here, and we notice that, oops. Okay, so if I pull my PowerPoint out here, so instead of negative 1.714 to 1.714 here, and our boundary now is negative 24898 and the 2.48988. So that was my critical value. So basically that decision rule, after we know the critical value, sorry, should be called rejection rule. Number 3. Rejection rule. So the rejection rule is that if t stats smaller than critical value left tail or t stats larger than critical value right tail, because that's when we are saying it's gonna fall into that rejection region, right? If then we will reject HO. Okay, so that will be my let me make it bigger. Okay, so that is my rejection rule. If the t stats, we calculate 1.5. If it is smaller than the critical values, left tails, so if it's less than negative 2.4, or the t stat we calculate here is larger than the critical value on the right hand side, 2.49, then we will reject. Okay. So as you can see that since this 1.4 is not belonging to this rejection rule, so therefore this t-stats, our decisions, will be since the t-stats is does fall within the rejection region, so we will not have enough evidence to reject HO. Okay, so therefore this is our conclusion, is we do not have enough evidence to reject 8 mu equal to 200. So we are not rejecting HO in this case because the critical value showing it is not fall into the rejection region. Okay, so this is one approach you can use to answer the question using the critical value approach. The other approach is called the p-value approach. So basically, let me pull the PowerPoint out again. So instead of focusing on the critical value here, we try to calculating the area we have. Are they falling to our rejection, whether they're going to be smaller than our critical value or not. Okay, so if we are using the p-value approach, okay, we're going to use so the step one would be the same. We still need to calculating instead of calculating the t-stats, we're going to calculate in the p-value. And the step number 3, the rejection rule will be changed, and the decision should be still the same. Okay, so therefore the second approach is a p-value approach. So the step number 1, like I said, still the same. I will skip. And step number 2, here we are calculating called a p-value two-tail. Sorry for the spelling here. So you need to make sure you know the formula we're going to use to calculating this the p-value here. Okay, so the t-test here we are using is different, called the t-dot dist dot two-tail, since we're working on the two-tail test. And here we need the input of x. So this x actually is the t-stats you calculated. And the degree freedom is still going to be the same. We're using the sample size -1 and close the parentheses. And you are receiving, this is a p-value. Okay, so this p-value will be 0.15437. And then step number 3 will be different as well. For the rejection rule, for using the p-value is if the p-value smaller than the alpha, whatever alpha you pick, then we will reject HO. Okay, now let's look at our decision here. Right, so if you look at, so our alpha is 0.025. The p-value we calculate is 0.15437. So therefore the p-value is actually larger than the alpha we picked. So therefore we are achieving the same conclusion, that is we cannot reject HO. But the reason will be different, since p-value 0.15473 is larger than alpha 0.025, so we will not have enough evidence to reject HO. Okay, not surprising, the critical value approach and the p-value approach should get exactly the same decision. So let's recap a little bit before we move on question number 2, B and C. Okay, so for both approach, the first and the fourth step will look exactly the same. And the difference is happening on the second and third step. So if you use the critical value approach, you need to follow the formula we learned in the class to calculate the t-stats. Okay, so you calculate the t-stats, and then using the formula using the Excel formula t.inv.2t here to calculating the right tail critical value. And then we're adding a negative sign to getting our left tail critical value. Okay. And then the decision rule is that if the t-stat is a smaller than that smaller critical value or larger than the larger critical value here, and then we will reject. Okay, so this is the main difference for the critical value approach. So if you use p-value approach, instead of just stop at the t-stat, you actually need to further calculating the p-value. So the way we calculate the p-value, we are using a different formula than the critical value. We are using DIST, stands for distribution. The other one we use inverse, right, INV. And it's still 2t. And the first entry in here is going to be the t statistic you calculate using a critical value approach. And then the degree of freedom. So that will give you the p-value. So that is different from t-stats, right? So this is the probability value. And the second difference, like I said, is the rejection rule here. We just need to use this p-value you calculated compare with the alpha you selected. So if it's smaller than alpha, then we will reject. Otherwise, we cannot reject. Okay, so now we're going to work on the other two questions. And we will keep reiterating these differences, and hopefully it will help you learn better. Okay, so now let's look at our second question, question number B. So question number B here is looking for mu larger and equal to 200. The H alternative is mu smaller than 200. So if the mu is smaller than 200 is your alternative, so you are looking for the left tail hypothesis testing. So because it's smaller, so it's left tail. So now let's recording all the numbers. So we are looking for the left tail. So therefore this table we are creating here. So this is going to be used to answer question number B here. So again, the sample size, let's just documenting on the number we needed. So the sample size is 25. And then the sample mean here is 198. Okay, and the sample standard deviation is 5, and the hypothetical value here we are choosing is still going to be 200. And then our alpha, in this question we pick 0.05. Okay, so this is all the information we needed to address question number B. Okay, so similarly as how we set up here, first of all, we need to know our hypothesis. Okay, step number 1, hypothesis. So HO is mu larger equal to 200, and H alternative is mu smaller than 200. Oops, smaller than 200. Make sure I double check. Yes. So that is my HO and the H alternative. Okay, step number 2, t-stats. Okay, so we basically just follow this exactly same formula, starting from calculating the standard error. So the standard error equal to the sample standard deviation divided by square root of sample size, close the parentheses. So that will give me the standard error that we're going to need for the denominator here, right? Now I can start to calculating the t-stats. So that will equal to parentheses. We will select the sample mean minus the hypothetical mean, which is here, close the parentheses, and then divided by the standard error we just calculated. So that gives me the value -2. Okay, so we are able to calculate the t-stat here is a -2. Perfect. Now let's move on to the step number 3, so the rejection rule. So the rejection rule for us in this case is, since it's a left tail test, let me pull this one out again. Okay, so if you think about the left tail test, okay, so the left tail test is trying to identify this critical value. So it's on the left tail, and to see after we calculating the critical value, will that value going to be smaller than the critical value? If that's the case, it falls into the rejection region. Otherwise, it will not. It will be not rejection region. Okay, so therefore, we need to calculating this left tail for what is exactly this value going to be. Okay, let me go back here. Okay, so here is the one you need to remember. The formula we're going to use, okay, so it's called equal to T dot INV. Okay, T dot INV parentheses. So T dot INV gonna give us the left tail critical values. So the probability here we're gonna use is the alpha. Here in this case is 0.05, and the degree of freedom is equal to the sample size minus 1. Close the parentheses. So now you are able to push enter. That will give you the critical value. Okay, negative 1.71. So basically step number 3, our rejection rule is if the t stats smaller than critical value left tail, we will reject HO. Okay, so basically this is gonna be my rejection rule. If t stats we calculate here is smaller than the critical value we calculated here, then we will reject. Now let's compare. So the t stat we calculate is -2, right? And then the critical value for the based on the left tail is -1.71. You can like imagine that normal distribution. So actually the t stats will be a little bit slightly smaller than this critical value we are calculating, right? So because -2 will be on the left hand side of your 1.7. So therefore the decision here will be reject HO because the t stats, which is negative because t stats -2 is smaller than the critical value -1.71088. Okay, so that is the answer for question number B. We actually end up rejected. Okay, so now let me show you the other approach, which is the p-value approach. I'm gonna put under here. So p-value approach, again, the first step is still the same, set up your hypothesis. And then step number 2, we're gonna figure out that p-value left tail. Okay, so how can we calculate the p-value for left tail? We know how to do the two tails, right? So how about the left tail? So same idea, we still have to know the t-stats. So you always need to calculate t-stats before you can calculate the p-value. So now I'm going to introducing this formula, make sure you know the differences. Remember the other one is the t dot dist dot 2t, so two tail, but since it's one tail, which is t dot dist, parentheses, selected the, where's the t-stat, sorry, the t-stats here, select the t-stat you already calculated, and a comma, then we are using the here, which is the sample size -1, and then close the parentheses and then push enter. T dot dis. Oh, I forgot the one entry, right? So since we always here we're gonna always use true. Don't worry about it. Just remember for this formula we're gonna always use true for the t dot dist. So true. Okay, sorry. So this is going to give us 0.02847. So that is the formula we're going to use. So you can see the difference, right? So for the p-value, we use a t dot dist. When we're calculating the critical value, we use a t dot inv because it's inverse. So this is one we directly use the t distribution. So that's going to give us the value 0.02847. So that is my p-value, 0.02847. And then the rejection rule is always be the same, is we're going to reject HO if p-value smaller than alpha. As you can see, compare this decision rule versus the other decision rule, you will find they are exactly the same. So that's why in the lecture I said people turn to use the p-value method more often than the critical value. It's just because the decision rule always going to be the same regardless what kind of test you're going to go through. It just always be reject HO if p-value is smaller than alpha. Okay, so if you look at here, our p-value is 0.028. Our alpha is 0.05. So therefore, we will reject HO because 0.02 is smaller than 0.05, right? So therefore, decision will be reject HO because the p-value 0.028 is smaller than alpha 0.05. Okay, so this is the answer for the question number B. Now let's look at question number C. Question number C, if you focus on the null hypothesis, mu larger than 200, so therefore you're looking at the larger side, that will be the right tail test. So therefore the table here I'm gonna creating is used to answer the question number C. It's really because we are each alternative is mu larger than 200. Okay, now let's adding all the information we needed for this question, right? So question number C, my sample size here, okay, let me put on this screen. Okay, the sample size here is 36, and the sample mean is 205. Sample standard deviation is 8, and then my hypothetical value is still gonna be 200, and then my alpha for this case gonna be still be 0.05, and then we're gonna do the calculation for the rest. Okay, so we're gonna fill in all the information given from the question. Now let's do the calculation. Okay, same step. Step number 1, set up your null hypothesis. HO is mu smaller or equal to 200. Like I said in the H alternative or H1 gonna be mu larger than 200. Okay, so this is step number 1. Step number 2, the t stats. Okay, again, use exactly the same formula we've been seeing many times. So for the t-stat, we're starting from calculating my standard error. Standard error is using the sample standard deviation divided by SQRT square root of the n. Okay, so that gives me this denominator here. Okay, and now let's calculate the t-stats. So t-stats will equal to the parentheses, the sample mean minus the hypothetical value, close the parentheses, and then divided by the standard error here. Perfect. Now after we do this, and then we can push enter. So in this question number C, the t-stats value actually equal to 3.75. Okay, now the next is the decision rule. So when you're gonna reject, let me pull my PowerPoint out again. Okay, so since we're looking at the right tail test, so we're gonna calculating the critical value first. So if the t-stats we calculated is belong to this area, which is larger than the critical value, and then we're gonna reject HO because it's gonna be in the rejection region. Okay, so therefore we're gonna learn how to calculate this critical value for the right tail first. Okay, so the way we calculating the right tail, we're gonna use Excel again, and then we do have Excel formula is called equal t.inv.rt. Okay, so for the critical value here, we still gonna use t.inv, so this version does not have right tail. So the key here is the probability. Remember for the left tail we used 0.5, but how about here? So I want to show you this diagram one more time. Okay, so basically we are looking at this size. Okay, so we use 0.5, but then we look at this size. So since we know this is going to be the complement event of the alpha, so therefore here instead of for the right tail, instead of using alpha, we're actually using 1 minus the alpha. Okay, so this is the trick here. So after that, and we are using the sample size minus 1, close the parentheses, and that's gonna give us the critical value 1.68957. And then we're gonna come back here. Let's see. Okay, so the rejection rule is if t if t stats is, again, it's a right tail, so if t stats is larger than the critical value, reject HO. Okay, so you see, let me enlarge this side a little bit. So we will reject the reject HO if the t stats is larger than critical value. Now compare the t stats, which is 3.75. It is larger than the critical value, 1.68. Therefore, we will reject. So the decision here is reject HO because t stats 3.75 is larger than the critical value 1.689. Okay, so now this is one method. So let me show you the p-value approach. So for p-value approach, here is the way. Same first step, I will skip it. So set out your H alternative, HO and H alternative. Now the difference here is what is your p-value. So the good thing for the p-value here is in Excel, we still use the t dot dist dot. We do have the right tail when we look at the probability wise. So we use right tail. RT stands for right tail. In the parentheses, we're going to select the t stats we already calculate. And then parentheses, comma, the degree of freedom are still going to be the same. Use the sample size -1, close the parentheses. And therefore, the p-value we got here is 0.0032. Okay, now step number 3. So step number 3 is my decision rule, right? Decision rule is still be the same as all the p-value method is reject HO if p-value is smaller than alpha. Now let's look at our decision for this specific case. So the p-value is 0.0032 and the alpha we pick is 0.05. So therefore we actually will reject. Okay, reject HO because p-value, which is 0.00032, is smaller than the alpha, which is 0.05 in this case. Now, this is everything we need to solve this case. So I know there's so many things to digest as you follow through this video. So I actually creating a cheat sheet for you so that you can easily to follow to learn, hey, when should I use this formula? When should I use that formula? So make sure you download that file to look a bunch of times and also leveraging that file when you start working on your homework assignment. And good luck. Bye.